In a sample reaction, sodium metal and water react as part of a single replacement reaction. We want to be able to predict and balance this chemical reaction. Sodium metal is Na solid if we look at the periodic table. Oh. Water, of course, is H2O. Now, this is going to be a single replacement reaction. How do we predict what it's going to become? Well, we can use a little trick with water as well. We can also write water as HOH. We don't like to do this normally, but this helps us look at water as if it's an ionic compound made out of hydrogen ions and hydroxide ions. Now, that hydrogen ion is a cation, which is the same type of thing sodium is going to become when it reacts. It becomes the Na plus cation. So we know that sodium is going to take the place of the water. That means, I'm going to give a little space. That means it's going to become NaOH, and that will be water soluble. We know this because sodium and hydrogen are both cations. Then what's going to be the other product? Well, hydrogen was the thing that got displaced, so we have to produce some hydrogen as well. And we remember that hydrogen is always H2 as a gas. Now we need to do a little bit of work balancing this out. We can see that we have sodiums, we have hydrogens, and for the purposes of this, we have hydroxide ions. There's one sodium, one hydrogen, one hydroxide ion in the reactants. There's one sodium, one hydroxide ion, but two hydrogens in our products. So we have to balance out the 1 and 2. That will give us 2, and we have to put a 2 in front of the water. Now that also changes our hydroxide ions to 2. So what do we need to do? We need to balance out the hydroxide ions on the other side. 1 times 2 gives us 2. We need a coefficient of 2 in front of the sodium hydroxide. When we change the sodium hydroxides, that also changes the number of sodiums. So we need to balance with one last 2. And we are all good here. Another, perhaps more typical single replacement reaction would be the reaction of magnesium and hydrochloric acid. So magnesium metal is Mg solid. Hydrochloric acid, remember, comes from hydrogen chloride. The hydro and ic means that the original chemical ended in IDE. So hydrogen chloride would be HClAq. Same sort of thing here. We can see that we have an ionic compound. We also have magnesium. Magnesium is going to become Mg2+. That means we're going to have the cation be replaced here. The cation always comes first, so that's the hydrogen. So we will produce MgCl2, because remember, the magnesium has a 2+ charge. We have to take that into account. So we need 2 chloride ions to balance it out. And then our other product is going to be hydrogen gas. To balance this out, we see that we have magnesiums, we have hydrogens, and we have chlorines. So magnesium, hydrogen, chlorine. We have one of each in the reactants. We have 1 magnesium, 2 hydrogens, and 2 chlorines in the products. Doesn't matter which one we pick. Hydrogen comes first in the list, so I'm going to do the hydrogens first. But really, I'm going to do both of them at the same time, because when we balance out the hydrogens, I need 2 to balance out a 1 and a 2. That's going to change the chlorines as well. It changes it by 2. Now everything is balanced in this chemical reaction. One last sample single replacement where chlorine and sodium bromide react with each other. Chlorine is Cl. Remember, this is another one of those gases that is diatomic, so it has to be Cl2. It's reacting with sodium bromide, NaBr. We want to know what will it become. This time it's going to be a little bit different because chlorine becomes Cl- when it ionizes. So this is going to be an anion instead of the cation replacing. The anion in this chemical is the bromine. So when we write the products, that means we're going to have sodium chloride because the anion got replaced, and we're going to have bromine, which is Br2, and it is actually a liquid at room temperature. Balancing this out is pretty straightforward as well. We see that we have 2 chlorines, so we need to double up on our NaCl's. We also need to double up on our NaBr's, and that will balance everything out. We have 2 chlorines on each side, we have 2 sodiums on each side, and we have 2 bromines on each side.